Welcome to Astrophysics. This unit is divided into 3 chapters: Motion in the Universe, the Properties of Stars, and Cosmology. So let's begin by talking about the motion in universe. Motion in universe. In this episode, we are going to look at what is the universe, what is the solar system, what is the gravitational field, types of orbits, and what determines the orbital speed. The universe consists of many billions of galaxies. And galaxies are formed from millions and trillions of stars, some of which host planetary systems. So we belong to the galaxy known as the Milky Way, where we find our star called the Sun, and all our planets are orbiting around that Sun. Talking about the universe, it is essentially the all of space, time, and their contents, which are galaxies, planets, stars, any other forms of matter and energy. So we know, as per the Big Bang theory, space and time started to exist 13.8 billion years ago, and the universe is expanding ever since. While we do not have any particular idea about the size of the observable universe, what we can approximately predict is that its diameter is 93 billion light years across. So we belong to the galaxy known as the Milky Way, which is 13.5 million years old, which has a radius of 52,850 light years and contains between 100 to 400 billion stars. Quite amazing, isn't it? So let's look at the solar system, which is formed around our Sun. The solar system was formed 4.6 billion years ago, when a dense hydrogen-rich cloud of gas and dust contracted under gravity. As this got compressed, its temperature increased and it began to spin. Soon after, protostar was formed at the middle of this cloud, and nuclear fusion reactions started. This was the beginning of the life of our Sun. Thereafter, the planets began to form from the swirling dust clouds around the Sun, and the 8 planets as we know today began to exist. Closer to the Sun, the gravity is enormous, and further away, the gravity is felt less. So here we have the 8 planets as we know today: Mercury, which is the closest to the Sun, then there's Venus, and where we call our home, the Earth, is the 3rd planet from the Sun. Next to us, we have Mars, then it's Jupiter, Saturn, Uranus, Neptune, and Pluto. However, Pluto is considered as a dwarf planet. The Earth is the 3rd planet from the Sun and is the only one known planet to harbor life. Tilted at 23.5 degrees from the plane of its orbit, it takes 365 days to complete one journey around the Sun. The Sun is 150 million kilometers away from our Earth, and the mean radius of the Earth is 6,370 kilometers. While most of the Earth is water, which is 71%, much less than that is only land, which is 29%. Considering the inner structure of the Earth, the innermost core contains solid iron, then the outer core contains liquid iron, which generates magnetic field, and the mantle is what drives tectonic plates responsible for earthquakes. So now we know what's there in our solar system. But that's not all. There's more other objects in the solar system other than the planets. So asteroids are rocky materials which are much smaller than a planet, but they still orbit the Sun. Then a meteorite is a meteor fragment that reaches the ground. And meteor is a streak of light that you see when a meteoroid heats up in the atmosphere. So what's a meteoroid in the first place? Now that is a section or a part of an asteroid which is also in an orbit. A comet is an icy body that releases gases as it orbits the Sun. And we'll talk more about the orbits of these things as we go along. The force which keeps everything in orbits is the gravitational force, which is one of the 4 fundamental forces in our universe. The Newton's law of gravitation states that the amount of gravitational force between two bodies is directly proportional to their masses and is inversely proportional to the square of the distance in between them. The closer the objects are, the stronger the gravitational pull is. G is defined as the universal gravitational constant, which is 6.67 times 10 to the minus 11 newtons per square kilogram square meter. The gravitational force between the Earth and the Moon is almost 2 times 10 to the power 20 newtons. Now these two forces are equal and opposite as per Newton's third law. The Moon is pulling the Earth at that much of a force, and the Earth is pulling the Moon towards its center at that same force of 2 times 10 to the power 20 newtons. You might have seen these high tides and low tides in the ocean. They are caused by the gravitational pull of the seawater by the Moon. Gravity and gravitation are two different things. Gravity is the Earth's gravitational field or pull on a body or near the surface of the Earth, whereas gravitation is the force of attraction between any two bodies in the universe. Gravitational field strength is defined as the amount of force acting per each kilogram of mass within the field of gravity. Any object placed within the atmosphere of the Earth feels a force of 10 newtons per each kilogram. If it was in the Moon, that will be much less, and on Jupiter, it's much greater. F equals mg, and F is also equal to g times m1 times m2 over r squared. We can cancel out the terms to come up with this equation: g equals capital G times capital M divided by r squared. So this means that the gravitational field strength depends only upon the distance away from the mass causing it and not the mass of the object in that field. Comparing different planets, the Sun has the greatest gravitational field strength of 293 newtons per each kilogram, which is why all the planets go around the Sun, whereas Earth only has 9.8 or approximately 10. The Moon is much lesser, 1.7 newtons per each kilogram, so you will weigh less if you step onto the Moon. But if you go to Jupiter, it's 24.7 newtons per kilogram. Whereas in Pluto, the gravity is much lesser, 0.49 newtons per each kilogram. And you can easily jump to much greater heights. The gravitational potential is defined as the work done per unit mass when you move an object from infinity to a point within the gravitational field. At infinity, the gravitational potential is defined as 0, and when an object moves from an infinity to that point, the energy is released as it reduces the GPE. Therefore, the gravitational potential is always negative. It's defined as minus g times the mass of the object divided by the distance between the centers of two objects. And the gravitational potential difference can be defined as the energy needed to move a unit mass between 2 points. Let's look at an example. Try to find the gravitational potential caused by the Earth at the distance of a satellite orbiting at 35,800 kilometers above the Earth. Pause the video and see if you are getting the answer using the formulae. V equals minus gm over r. Now r is the Earth's radius plus the height of the satellite, as we need the radius of the orbit. And when you put the values given in the question, we get minus 9.52 megajoules per kilogram of gravitational potential. Everything goes around the Sun in its own orbit. Depending on the distance away from the Sun, different planets have different orbital speeds. Orbit is caused as a result of the balance between the forward motion of a planet and the centripetal force of gravity caused by the Sun. So the Earth's orbit is something like this. As the Earth is 23.5 degrees tilted, at one point, the North Pole of the Earth faces the Sun very much than the South Pole, and this causes summer in the North Pole, which is July in every year. The other extreme, after 6 months, the Earth's South Pole will face the Sun more than the North Pole, and this causes summer in the South Pole and winter in the North Pole, which is during December. The Earth is at different distances away from the Sun at different points of its orbit. During July, it's 152 million kilometers away from the Sun, and in January it's 147 million. So while the planets go around in orbits, they also spin around their own axis. Just like the planets have their orbits, the asteroids also contains orbits. They go around the Sun in asteroid belts. The most famous asteroid belt is known as the Kuiper belt. A comet also has its own orbit, but goes around at a different plane, at a much different angle. Halley's Comet, which has a period of 75 years, can be observed once in every 75 years, and it has a highly elliptical orbit, which is at a very steep angle. So as it goes away from the Sun, it is a ball of ice, but as it comes closer to the Sun, it becomes a streak of fire. So the last known year of the Halley's Comet is 1986, and the next time we'll be able to see is in 2061. Satellite is anything that orbits a celestial body. It could be natural or artificial. Natural satellites are the moons. The Earth has only one natural satellite, which we call the Moon. So it's locked into the Earth's gravitational field and orbits once every 27.5 days. Depending on the planet, there could be much bigger number of satellites orbiting those planets. So when the Moon orbits the Earth, it's facing its same side to the Earth every time, which means it takes the same time to spin around its own axis as it takes to go around the Earth. Just like the Earth being at different distances away from the Sun, the Moon is also like that. At one point, it's 405,400 kilometers away, which we call the apogee, and at another, it's 362,600 kilometers, which is the perigee. So this is how a 3D animator's viewpoint is with respect to the Moon and Earth going both together around the Sun. And as the Sun is blocked by the Earth during its journey, we see different shadows, which we give different names. Every time we see the full moon, we call it a full moon day. Artificial satellites have been sent by humans for various purposes, mainly for telecommunications and television, then for satellite navigation systems, which we call SatNav, and for military applications or for weather forecasts. If the satellite has enough escape velocity, it could leave the Earth's gravitational field and it could basically continue in a straight line. But if its forward velocity is balanced by the centripetal acceleration due to the Earth's gravity, then it follows a circular orbit around the Earth. At a speed of 7,600 meters per second, the object goes into the orbit, and if it exceeds 11,200 meters per second, it will leave the Earth's orbit. But if the speed is less than 7,600 meters per second, it will fall back to the Earth. So this is called a geostationary communication satellite, which has the same orbital period as the Earth turns on its own axis, which is 24 hours. So it can stay above one particular country always. Sputnik 1 is the first ever man-made satellite that was sent into the orbit by the Russians in 1957, and it lasted for 3 months. Today, there's more than 3,000 active satellites that orbit the Earth for various purposes. Orbital speed is defined as the distance around the orbit divided by the time taken to complete that distance. Orbit is a circular pathway, so the distance is given by the circumference, which is 2 pi times the radius. That is divided by the time taken to complete the orbit. As the Earth is at different distances away from the Sun at 2 different points, the orbital speed also varies accordingly. At aphelion, it's 29.3 km per second. At perihelion, it's 30.3. The closer the planet is to the Sun, the stronger its gravitational pull. So Mercury takes just 88 days to complete one orbit around the Sun. So this graph shows how the orbital speed varies with the distance away from the Sun. This brings us to the end of the first episode. So we looked at the universe, the solar system, the gravitational field, the types of orbits, and the orbital speed. If you have any questions, please feel free to leave a comment. Thank you very much for listening.